So this little presentation is about vectors. Vectors are the absolute ultimate building block in R. So let's take a look. Here's the table of contents, all of the things that I'm covering in this presentation. You might use this later on to go back if you want to get to a particular part of it. So what is a vector? It's an ordered collection of values, and you can reference the individual values in a vector with an index. And in R, indexes begin with 1, unlike Python, where indexes begin with 0. And here's the most basic way to create a vector is to use the C function. C stands for concatenate or collect or combine or cram together. I don't know, think of whatever words you want. So here I've created a vector. Vector underscore 1 is the C of 23, 2, minus 4, and 7. And then I ask for the third element in vector 1, and I get the minus 4. Here I get vector 2. It is a vector of strings, cat, dog, parrot, and Python. And if I ask for vector 2 of 3, I get parrot. And I can also use that referencing to reset a value in a vector. So I said vector underscore 2 of 3 is hamster. And now if I look at vector 2 again, I've got hamster. Okay, so here's the important thing. You need to stop right now, and in your own environment, whatever you're using, you need to make up some simple examples of vectors created with the C function. So pause the video, and after you've done a little bit of playing around with this, come back and we'll talk more. Okay? Okay, you're back, so let's go on. You can use the C function not only to create things from really basic elements, but you can take existing vectors and can cram them together with the C function. So here I've created something called vector 3. So it's the concatenation of vector 1 and vector 2. And notice that vector 1 and vector 2 were a little bit different. Vector 1 contained numbers. Vector 2 contained strings. And in a vector, there can only be one type of object. So what R had to do was it used the sort of the least common denominator. You can represent all numbers as strings, and that is what it did. So vector 3 is just a vector of string. And this is called coercion. Okay? So again, please pause and do a similar example of your own, and then come back and start the video again. Okay, you're back, so let's go on. It is possible to extend a vector. So this time I combined just an original vector and another simple element. And I said vector 1 of 6 is 10. Well, let's see what's going to happen. I got 1, 2, 3, 4, 5, 6. Okay. Vector 1 of 9 is 25. You notice that in vector underscore 1, there were no 7 or 8, only 6. So what happens is that when you do that, you get some NA values. Okay? So again, stop the video, make an example of your own to illustrate the points that are made on this slide. Then come back, start the video again, and we'll talk some more. Okay, you're back. Names. Here I've created a vector called weight, just 3 numbers. And I've created a vector called Stooges, Larry, Curly, and Moe. And then I declare the names of the weight vector to be the Stooges vector. And then I asked to look at weight. And after I've given a vector names, when you look at the vector again, you'll see it displayed with the names. So Larry's 180, Curly's 150, Moe is 210. Also, now that you've got names, you can refer to individual elements in the vector using the appropriate name instead of the index. It doesn't change the fact that you can also still refer to the vector item with a numeric index. So I can either call for the weight of Larry, or I call for the weight of item 1. And here I'm using the name, Moe, to change Moe's weight from 210 to 190. And after I've done that, when I look at weight, I've got clearly the new weight for Moe. Okay, as always, stop the vector, or stop the video, and make up an example or two of your own to use a named vector. Then come back and restart the video again. Okay, you're back. Let's go on. There are a couple convenient functions which you can use to create vectors. And this is the rep or repeat function. So this says nines is repeat 9 20 times. And if I then ask to see nines, what I see is 29s. Okay, as usual, stop the video, make up an example of your own using rep, and then come back and restart the video. Okay, you're back. Another thing is the sequence function, SEQ. It has 3 arguments, from, to, and by. So this example says 5 underscore 2 underscore 20 is the sequence, from equal 5, to equal 20, by equal 0.5. And here it is, 5.0, 5.5, etc., 19.5, 20, etc. Okay. So again, as usual, stop the video, create your own example of the sequence function, then come back and restart the video. There's a simple way to specify a sequence of integers without using the SEQ function. It's just first integer colon last integer. And here I've created the vector x, which contains the integers from 10 through 25. Okay? And again, stop the video, make your own example, then come back and restart the video. Okay. Element-wise computation. What happens when you do arithmetic with vectors? So I've created 2 vectors. X is 1, 2, 3, 4. Y is 5, 6, 7, 8. And Z is X plus Y. And I've got the first element of Z is the first element of X plus the first element of Y, which is 6, and so on. If I take the square root of a vector, what it does is it calculates the square root of the first element, the square root of the second element, and so on. Okay? So as usual, stop the video, make your own example, then come back, restart the video. Okay, you're back. Extracting pieces of vectors. Well, we've got one way to do it is just to supply the indexes. So remember that the vector y was 5, 6, 7, 8. And I've created a little vector y part, which is y extending from 2 to 3. And that gets me the 6 and the 7, the second and third elements of the vector. You can also specify which parts of a vector you want using Boolean values, false and true. So y part 2 is we do want the first, we don't want the first, we do want the second, we do want the third, and we don't want the fourth. So y part 2 is 6 and 7. So these are just alternative ways of extracting a pair of elements from the original vector, making a shorter vector. As usual, stop the video, make up your own examples of pieces of vectors, then come back and restart the video. Okay, you're back. The recycling rule. We've seen element-wise computation, and you might think that if you did that with two vectors of different lengths that R would complain and spit at you or something. And that's not what R does. R uses what we call the recycling rule. That is, here I've got a vector that's 4 long and a vector that's 2 long. And what happens when I create the sum of those two vectors? It recycles. It just says 1 minus 1. Okay, well that's not enough, so we need another 1 minus 1. So I've got 2, and then I subtracted 1, then I added 1, then I subtracted 1. So you see it used the vector 1 minus 1 twice. It recycled it. And here's the same thing with multiplication. And here's an interesting example using Boolean values. X bracket, and then I give a vector of Boolean values, true and false. And what this says is, take one, skip one, take one, skip one. That's the recycling rule with a Boolean extraction vector. Okay, again, stop the video, make your own example, then come back and restart the video. Okay, you're back. A number is not just a vector. A number is not just a number. It's a vector of length 1. So here I've got x equal 3. You might think x isn't a vector. It's only got one value in it. Well, sorry, it is the length of x is 1. And this says that these square bracket things out here to the left when you're displaying the values of vector tell you which values are going to appear to the right. And look, I can even do that with a constant 3. So 3 is really just a vector with a length of 1. Okay, so that's the last slide. And what I want you to do, of course, you're not going to come back, but make yourself up an example or two of this thing, okay?